This video, what I wanted to take a look at is, some of the applications of your systems of equations, when you would need actually two variables when you're solving these. Okay, so we have a couple examples up here. It says the number of adult tickets sold to a play was 25 less than twice the number of children's tickets. The cost of an adult ticket is $6 and the cost of a child's ticket is $4. If the play brought in $410, how many adult tickets were sold? So anytime your word problems involve two unknowns, you can always use the option of, setting up two variables and two equations. Now, that doesn't mean you have to do it that way. This problem can be solved just using a single variable. Picking one of these unknowns, there are two unknowns, but picking one of the unknowns as a variable and writing the other in terms of that. I'll kind of show you as we go through this, but the idea was I wanted to show you how this is done using two variables. All right, so we have to ask ourselves the question, what are the unknowns in this problem? And we got to be specific. We can't just say children's tickets, adult tickets. No, there are certain things we know about those, and there are certain things we don't know about those. So let's be very specific. Usually the final sentence kind of clues us in as to what would be a good idea to label our variable as, or variables in this case. So if the play brought in $410, how many adult tickets were sold? So obviously we don't know how many adult tickets were sold, so that could be one of our unknowns, the number of adult tickets sold. Well, obviously what would be the other unknown, that would be the number of children's tickets sold. So I think we have our labels here. So maybe we could say, let's let A represent, I'll just do the hashtag symbol, number of adult tickets sold. What I found over the years, the more descriptive you are with your variable, what it represents, the easier it becomes to write your equations. All right, so A represents the number of adult tickets sold, and C, we could say, is the number of children's tickets sold. Children's tickets sold. All right, so we're very clear about what our unknowns are. Now, how you would treat this as a one variable problem, we could do this. The number of adult tickets we could call A, and there is a relationship between how many adult tickets and how many student tickets were sold, and we could write that in terms of our A. Okay, well, let's get further in this problem using the two variables, and then we'll backtrack and show how it could actually be done using one. All right, so the rule is if you use two variables, or if you identify two unknowns, two different variables, you have to have two equations. You can't solve a single equation that has two variables to it, two unknowns. So we'll start off here. The number of adult tickets. We'll start there as the number of adult tickets sold, A. Was is the past tense of is, but in mathematics we know that means equals. Now we say 25 less than. We're talking about subtraction here, but that phrase less than always reverses the order. So the 25 less than has to come second. We're going to be subtracting 25 from twice the number, here twice the number of children's tickets sold. So first equation, A equals 2C minus 25. Now, as far as if you wanted to use this or do this in a single variable, you could just simply call the number of children's tickets, we could call it the number of children's tickets C, and the number of adult tickets would be 2C minus 25. And then we would only need one equation. But in essence, it's really not any more work with two variables. All right, so there's our first equation using two variables. We need a second equation using those two variables again. And we go to the cost. So the cost of an adult ticket is $6, and the cost of a child's ticket is $4. The play brought in $410. So if we take $6 and multiply it to the number of adult tickets, 6A represents how much money the adults brought in ticket sales. Add that to the amount of money brought in by the children's ticket sales. Add those up, and what you're going to get is the total amount of money brought in ticket sales for the play. All right, so there you have it. Those are your two equations. This is your system of equations that you're going to solve. Probably, I would personally use substitution. Because if you take a look, You already have one of the equations solved for the variable, in this case, variable A. We're going to take this and we're going to substitute that in for the correct variable in the other equation. So the second equation says 6a plus 4c equals 410. Well, substitute in 2c minus 25 for a. And what we get is we get 6 times 2c minus 25, and then we add 4c, and that should equal 410. And again, what's the point of this substitution step? Well, the point is you now have another equation, or a third equation, but it only has one variable to it. So let's finish solving this. We distribute 6 times 2c is 12c. 6 times 25, that would be 150, plus 4c equals 410. We'll combine our c's together for 16c minus 150 equals 410. Add 150 to both sides. So 16c gives us what? 560. Divide both sides by 16. Hopefully this comes out nice. So 560 divided by 16 is 35. Now I say hopefully it comes out nice, because if it doesn't come out nice, we kind of have a problem. We don't sell fractional parts of tickets. So if you got 35.43, we got a problem. You don't sell 0.43 of a children's ticket. So it was very important that this came out not only just an integer, but a positive integer. Right? No decimals, no fractions, no negatives. All right, so 35, what does that represent? Well, what was C? C is the number of children's tickets sold. So we know that we have sold 35 children's tickets. Question, though, asks how many adult tickets were sold, which just means we have to finish off the substitution process. C is 35, and A is equal to 2C minus 25. So if A equals 2 times C minus 25, and C is 35, well, one step away from finishing this. So that's 70. Subtract 25 puts us at, what, 45. So to answer the question, 45, let's say 45 adult tickets sold. Always label your answer. Now, again, if we would have just gone with one variable and say, okay, what we don't know is the number of adult tickets sold, we don't know how many children's tickets were sold, but we can write one in terms of the other, where we would say, okay, let's make children's tickets sold C, just like we did here, but let's make adult tickets twice of C minus 25. And then you would go from here and say, okay, let's go to the total amount of money brought in. We'd multiply this guy by $6 a ticket. We would multiply this guy by $4 a ticket, because these are representing how many tickets were sold, multiply it by its value, and now you're talking about the value brought in, and you're going to get exactly this equation, which is what we got. So we did it through two variables in substitution, but you could definitely go through one variable. It just makes the first step a little bit more challenging to write. I mean, this was not difficult saying A and C. Those are my unknowns and then describing what they are. But the problem is the back end of that is you got to write two equations. Use one variable, the first step's going to be a little bit tougher for sure, but the back end is you're only going to have one equation. So it's pretty much a wash. It's the same amount of work just about any way you slice it here. Let's try a second one. For this one, we have a collection of 42 coins. All dimes and quarters is worth $8.55. How many of each coin is in the collection? So again, let's approach this from a two-variable perspective here. So it's a collection, all dimes and quarters. What we don't know, I guess we could say D, being, again, number of dimes in the collection. We could say Q is number of quarters. And as I said before, if you go with two variables, you're going to have two equations. Right? That's the only way you can solve a word problem that has two unknowns to it, is to write two equations. So we have 42 coins altogether. Well, that would mean the number of dimes plus the number of quarters should be 42. So there's my first equation. Now the second equation, just like the last problem, has to do with value. Right? We're talking about value. A dime and a quarter aren't worth the same. A dime is worth 10 cents. So if you multiply 0.1 times D, 0.1 times all the number of dimes you have, what you're going to have is the total value of all the dimes in the collection. Add that to the total value of all the quarters in the collection. What that's going to give you is how much the collection is actually worth, assuming it's only dimes and quarters, and that's what we're assuming here. Well, all dimes and quarters. I guess I needed a parenthesis there. That would have made more sense. Equals 8.55. All right, you got yourself a system of equations. You solve this. Again, we could do substitution by simply solving the top equation for D or Q, or we could do elimination, whichever. It really should not matter. I'm going to try elimination just to be different. I'm going to take the top equation, multiply it by negative 0.1 to eliminate the D's. I just have to make sure I multiply everything by negative 0.1. So let's group these together. I get negative 0.1 D minus 0.1 Q equals negative 4.2. It's easy to multiply by 0.1. Okay, and then 0.1 D plus 0.25 Q equals 8.55. Okay, the elimination method says add them up, and you should be able to eliminate a variable. And we made sure that happened. The D's eliminate. We got 0.1, negative 0.1 plus 0.25, which would be 0.15 Q equals, all right, $8.55 minus $4.20 puts us at $4.45. $4.35. That worked really well. $4.35. We'll go there. All right, so from there, I just go to a calculator to crunch this out. So just check that. Yeah, 435, and we'll divide that by 0.15. We get 29. And in fact, that gives us how many quarters we had. I already forgot, 29. Yes, 29 quarters. And from there, we could easily go to this first equation and say, okay, if we have 29 quarters, how many dimes are we going to have if there's a total of 42? You're just plugging it back into that equation. So we'd say D plus 29 equals 42. Subtract 29 from both sides, and what are you going to get? 11 and 2 is 13. So we would say 13 dimes and 29 quarters.